Hey everybody. So I got a homework question from a student today, and I thought this is a good opportunity to show how I can help you with the homework questions. So this is chapter 14 assignment. As you can see over here, assignment, chapter 14 assignment, and this is going to be number 4. This is a pretty straightforward application of what I was showing in the chapter 14 videos about doing regression in Excel. And I just wanted to show you some tricks that can make this problem possibly easier than approaches you're taking, but your approach is probably fine too if you're not struggling at all with this one. But I just want to show you how I would approach this problem. So I'm going to go ahead and use Excel for this. So I'll open Excel, a blank workbook, give ourselves some space so you can see my pretty face. Oh, it rhymed. That was sweet. That rhymed, you guys. All right, let's check this out. So with a lot of these homework problems, you can actually copy and paste the data pretty easily into Excel. So I just highlighted the data and the names, Control C, go over to Excel, Control V, and that worked out pretty nicely. Sometimes maybe you have to do like text import if it's like a weird, if the way they're presenting the data is weird, but this one works out really nicely, at least on my Excel. So then we'll go ahead and we're going to do a regression because this problem asks, an important application of regression analysis in accounting is the estimation of cost. So we're going to be estimating cost. That's your first clue that cost is going to be the dependent variable. By collecting data on volume and cost and using the least squares method to develop an estimated regression equation relating volume and cost, an accountant can estimate the costs associated with particular manufacturing volume. Consider the following sample of production volumes and total cost data for a manufacturing operation. So that's the data we just put in Excel. The first thing it wants is B1 and B0. As you guys know, that's our sample slope and our sample intercept. So let's go to data. I'm going to do data analysis, regression. That's already loaded in there because I tried it. But I believe it will look like this when you start. So let's work with that. So our Y range, that's our dependent variable. That's going to be total cost right here, B1 to B7. Our input X range, production volume, independent variable right there. So this is going to be a simple linear regression because we have one independent variable. I included the labels, so I have to make sure that's checked. That will not be checked. I forgot to uncheck that to show you what the default would look like, so you have to make sure that's checked. Otherwise, it'll say, hey, you're not giving me numbers in some of these cells, so that's a problem for Excel. I'll put an output range. I'll put that guy right here. Okay. So here are our results of our regression. And we can zoom in on that a little bit. So coefficients, that's where your B1 and B0 is going to be. This is actually going to be B0 right there. And this is going to be B1. So Excel just calls B0 your intercept, which we know that's what it is, sample intercept. And then when we include labels, it will label the slope with the name of the associated independent variable. As you guys seen from multiple regression, that can be helpful the second you add more independent variables. So it's like, oh, which slope is this? Because otherwise it'll say like variable 1, variable 2, something like that. So let's interpret this slope real quick now that we have a chance to. When production volume increases by 1 unit, costs increase by $7.6 on average in this data. Okay? Intercept, 846.7. Does that make sense to us? Maybe it does in this have a sensible interpretation. When production volume is 0, the cost is $846.70 about. That might be true in a lot of business environments. Like your employees show up and you're like, hey, you're not going to make anything today. I've worked at restaurants where like sometimes no customers come in. I still get paid for that like 9 a.m. hour at the Thai restaurant where no customers come in. So like I'm getting paid when there's no production. So that might be interpreted as a fixed cost of being in business or something like that. So let's go plug those in. This says it wants those compute B1 and B0. Sorry, this is small type. was trying to zoom in, but I would just open your version of this problem and you'll be able to see it obviously easier on your computer. So B1, that is our slope estimate. It wants 1 decimal point. That's going to be 7.6. B0, right there, I labeled it. That's my intercept estimate. 1 decimal point, 846.7. Okay. Now we can write the equation. This is just using those same 2 numbers and it still says 1 decimal. So the intercept is the thing that is not being multiplied by x. That's 846.7 plus the slope times x. What is the variable cost per unit? Notice we just talked about the intercept is the fixed cost. Well, the variable cost means how much does your cost go up per unit of production? Well, that's the slope, 7.6. Compute the r squared. Well, Excel gives us that. That's right here. This is a very well-fitting model. 95.9% of the variation in cost can be explained by variation in production volume units. That would be the interpretation of that. That would be a good type of interpretation you'd want to put like in your project or something. So 95.8%. Here it wants the decimal version, 0.958. So I just, 959, make sure your rounding is right in there. Now it says, just interpret that to in percentage. What percentage of the variation in total cost can be explained by production volume? 95.9%. So I just moved the decimal plate over a couple places. The company's production schedule shows 500 units must be produced next month. So let's predict the cost of producing 500 units using our predicted regression equation. So I'll just go down here and say equals intercept plus slope times 500. And now I have estimated or predicted a cost related to a production volume. Notice that production volume is not one of the ones in the underlying data because you can use your regression line to predict whatever you want. And that's a cool thing to do with your project too. Hey, look, I can predict other stuff now that I have this equation. And that's like really big in business environments. Predicting out of sample stuff I've explained before. When I was an analyst, that was a huge part of my job. The majority of my job was using regression equations to predict other stuff. So like predicting costs. I was predicting natural gas storage. You can imagine predicting costs would be huge for companies, for government agencies, all types. We want to know about costs because that's really economically important in business environments. Enter 4646.7. It wants a whole number, so that's 4647. 4647. And then it looks like we have everything. We cross our fingers. Check my work. Boom. Sweet. See you guys later.